All right, today we are going to be looking at solving systems of equations algebraically. The other day we looked at solving them graphically. We looked to see where they intersected. Today we're going to talk about how to do that without needing some graph paper. We're going to do that algebraically. So one way that you learned in Algebra 1 to solve a system of linear equations was by this process called substitution. And there are other ways you can solve systems of linear equations, like by elimination. But elimination doesn't work for all types of systems. But substitutions is usually a pretty good bet. So that's what we're going to focus on, first of all, reviewing today and then doing. So when we substitute, we want to pick one equation to simplify, well, I guess just to rewrite so that one variable is isolated. I see I have an x, a 4y, a 3x, and a 2y. And in observing these different variables, it's going to be very easy for me to isolate that x because our coefficient is 1. So let's isolate that and let's rewrite what that would look like. So if I were to isolate x, that is going to be 1 minus 4y, or negative 4y plus 1. So this is the equation that we're going to put in to the other one. Now the other equation is 3x plus 2y equals negative 12. So but in place of x, what I can do is put the 1 minus 4y. Now I can continue with the equation, plus 2y equals negative 12. So all I did was replace the x with this new expression, 1 minus 4y. Well, now this is a one variable equation that you can solve. We can distribute the 3 to make 3 minus 12y plus 2y equals negative 12. We can combine these terms, the negative 12y and 2y. So that would give me negative 10y. I also have this 3, so 3 minus 10y equals negative 12. I can then move the 3 over to the other side. That negative 10y equals negative 15. And then I can divide both sides by negative 10. And the two negatives become a positive. The 5, I can cancel that out, and so I get that y is 3/2. Now I'm not going to happy cloud that just quite yet because we know from our other conversations that a solution to a system is an ordered pair where they meet. And this is only the y coordinate. So what we'll do is we'll put that back in to find what the x value is. So our x value is going to be 1 minus 4y. Now we can substitute this y value we know in there. I know some of us are kind of weak with fractions. Think about 4 as 4 over 1 times 3 over 2. Notice that 4 over 1 times 3 over 2 we can multiply across. 4 times 3 gives 12. 1 times 2 gives 2. And so that tells me that that gives me a 6. And then I can take 1 minus 6 to get negative 5. And so then my solution would be negative 5 3/2. And I could substitute that in, and just for time's sake I won't, but I could substitute that negative 5 in for x and the 3/2 in for y. I'll do it real quick. And we would get negative 5 plus 6 equals 1. That checks out. And then I could also substitute that in here. 3 times negative 5 is negative 15. 2 times 3/2 would be 3. Negative 15 plus 3 is negative 12. That's correct. We know that's the solution to our system. Okay? And this is something that you guys did in Algebra 1, where we had, if we found a solution, there was going to be one solution, and this is where those intersected. Now this is, the reason this is nicer than graphing is because it's hard to find those fractional values when you're graphing. But notice that in algebraically, they pop out pretty nicely and they're pretty easy to deal with. So again, you guys solved systems of linear equations in Algebra 1, but again, we're going to spruce it up in Algebra 2 and solve linear quadratic systems. So that means one will be linear, but one is going to be a quadratic. Well, let's start with something that's pretty basic. We have x squared plus y minus 3 squared equals 25. What type of shape would that be? Well, since both x and y are squared, we're adding, that looks like a circle. And then we have this y equals 6. And we discussed that linear quadratic systems can have 0, 1, or 2 solutions. So let's see how many solutions this one has. The first thing that we want to do is isolate one of the variables. Well, we look in the first equation, and that just looks like that would not be any fun at all. Luckily, our second equation is already pretty simple, right? It's just saying that y equals 6. So that means that we're going to put this into this other equation. So I have x squared plus, and then in place of the y, I can put that 6. Minus 3 squared equals 25. So again, I substituted. This time it was just a number. So I substituted that y value of 6 in place of the y in this equation. Well, now I can find the rest of I can simplify to try to solve here. Well, 6 minus 3 is 3. So I have x squared plus 3 squared equals 25. I can simplify 3 squared to make that 9. X squared plus 9 equals 25. I can subtract 9 to get that x squared is 16. And we know that we take the square root of both sides. But when we take the square root, remember that we need to consider both the positive and the negative square root. So I end up with x being plus or minus 4. So it looks like there are two possibilities for x. Now again, we're not done with this because we're solving a system, and a system is going to have x coordinates and y coordinates. Well, in Algebra 1, we took the coordinate we found and substituted it back to find the other coordinate. So we have two coordinates to use here. We have positive 4 and negative 4. And oftentimes we substituted into that equation that we used as the substitution expression. But notice that y equals 6 is telling us that regardless of what x is, y is going to be 6. So I'll just make a little note here, is that we see that y equals 6. So that means that when x is positive 4, y is going to be 6. And when x is negative 4, y is going to be 6. And those are going to be my two solutions. And if you substituted those values in here, 4 squared is 16. 6 minus 3 is 3. 3 squared is 9. 16 plus 9 is 25. Same thing would happen if we took negative 4 and substituted it in. So these both work in the first equation and obviously in the second equation since y equals 6. And those are your two solutions. Let's spruce things up a little bit in example 3. Instead of just substituting in a number, let's make it a little bit more complicated. So in example 3, we have y squared equals 8x and y equals 2x. Well, to solve for y squared, we would have to have square roots and plus or minuses. That would be a mess. To isolate x here, we'd have to divide by 8. This y already is isolated and equals 2x. So why don't we use that? Let's use this. It has a leading coefficient of 1 and it's already isolated. So what that means is that we're going to substitute that into this second equation. We'll notice, I guess the first equation. So this first equation says y squared equals 8x. So y squared equals 8x. Well, right here, we said that y was the same as 2x. So when I substitute this expression into this equation, I get 2x squared equals 8x. Well, this is one variable. This is solvable. 2x squared is the same as 4x squared. And it looks like now I have a quadratic that I can simplify, or I can solve, because we could get one side equal to 0. And it looks like we might be able to factor this. We wouldn't want to solve by square roots, but this looks factorable, and that's a very efficient way to solve quadratics. We can pull out a GCF. Don't forget, guys, sometimes that's all you've got to do. So we pull out a 4x. That gives me x minus 2. So I have 4x times x minus 2 equals 0. And then I can set each of these equal to 0, and I get that x is 0 when I set 4x equal to 0. And setting x minus 2 equal to 0, I get that x equals 2. Well, remember, these are only x coordinates, so we have to find the y coordinates. So I'll do that over here. Let's find the y coordinate when x equals 0. Well, when x equals 0, I need to put that in to find y. So to find y, I'm going to have to multiply 2 times x, in this case 2 times 0. And I find that y equals 0. So that means that one of my solutions is 0, 0. But that wasn't our only x value. We also need to find out what happens when x equals 2. So once again, I'm going to use that equation we used to help me find what our y value is going to be. So when x is 2, that means that y is 2 times 2, so y equals 4. So that means that when x is 2, y is 4. So another solution is 2, 4. And those are my two solutions. And if I substituted 0, 0 into both equations, it's going to check out. Same thing if I substituted 2, 4 into both equations. They check out. So those are our two solutions. Okay? So let's do something else. Let's try example 4. We look here. This looks like a circle and a line. Oh, and how nice is that? This y is already isolated for us. So let's use that and substitute that in for y in the other equation. So I have x squared plus y squared equals 10, but in place of y, I can put this negative 3x plus 10. And I can do that instead. So let's try to make sense of this a little bit. Remember, when you're squaring something, you're multiplying it by itself. So I don't want to be tempted to distribute a square over addition, because that's illegal. We don't want to end up in math jail. So I'll write negative 3x plus 10 squared as negative 3x plus 10 times negative 3x plus 10. And I'll bring down the x squared so I don't forget about it. And let's see what happens when I multiply these out. Negative 3x and negative 3x gives me positive 9x. So I can write positive 9x squared. My outer is negative 30x. My inner is negative 30x. So my outer and inner would combine to make negative 60x. And then my last 10 times 10 gives me 100. Okay? So now I could combine like terms. X squared plus 9x squared gives me 10x squared minus 60x plus 100 equals 10. And I see that I have a quadratic, and we usually like to get one side equal to 0. That sounds good. So we could subtract 10, and so I end up with 10x squared minus 60x plus 90 equals 0. Well, those are kind of big numbers, but I noticed that there's a GCF I can take out. I can take 10 out of everything. That'll make things a little bit nicer. So I have x squared minus 6x plus 9 equals 0. And hopefully you notice that this is factorable. This is a perfect square trinomial, a PST. So remember that there's a perfect square here, there's a perfect square here, and if I multiply and double, I can get negative 6x if that 3 is negative. And remember, perfect square trinomials factor as a quantity squared. So by factoring, I end up with 10 times the quantity x minus 3 squared equals 0. Well, this is factored, so now I can set each factor equal to 0. Now, you guys, 10 doesn't affect it at all. 10 doesn't have an x with it, so 10 is not going to be a solution or affect our solutions at all. But this factor, x minus 3, we could set that equal to 0, and we can find that x is 3. Now remember, this is a system, which means that we need an x and a y coordinate. So let's maybe find our y coordinate. And we can find our y coordinate by substituting this 3 back into this equation here. So when I have x equals 3, I can use y equals negative 3x plus 10, but put the 3 in for the x. Again, I just used that equation that we used up here, that we used to substitute into the other equation. That's usually a nice place to find what the other variable is. And I see that gives me negative 9 plus 10, and I see that gives me that y equals 1. And notice there was only one x value for me to use. So that is going to be my only solution, is 3, 1. Because remember, we said that linear quadratics can have 2 solutions, but sometimes there's only one solution, and sometimes there's none. Right? So you can see it's very similar to this process. It's just that instead of solving linear equations, we have to use our knowledge of solving quadratic equations by using square roots, by factoring, etc. Okay? All right, let's look at example 5. In example 5, well, let's see, we don't have any variables isolated. And this one looks okay, though. This one looks like we could isolate y pretty easily. We could add 3x to both sides and get that y equals 3x plus 6. So maybe let's use that as the expression for us to substitute in, the expression that's equivalent to y. So let's use this other equation. I have 8x plus y squared plus 24 equals 0. So I have 8x plus, and then I have y squared plus 24 equals 0. But we know that y is the same as 3x plus 6. So maybe let's put that in, and now we have an equation with one variable that we can solve. Again, we have a quantity squared, so we can write that quantity multiplied by itself. So I'm going to rewrite 3x plus 6 squared as 3x plus 6 times 3x plus 6. Again, I'll bring down the 8x, and now I'll distribute here. So I have 3x times 3x, that's 9x squared. My outer 3x times 6 is 18x. My inner 6 times 3x is also 18x, so 18x and 18x would make 36x. And then 6 times 6 gives me 36. And then let's not forget this plus 24 that's over here, and then equals 0. Notice all of these are equivalent to each other. So let's combine like terms. So the only x squared term is 9x squared. I have 8x and 36x. That gives me 44x. And then 36 and 24 gives me 60. Okay. So I look at this. Not sure if I can factor. So let's see. We could try. Did I tell you guys the trick about factoring if you're not sure? If you're not sure if you can factor or not, what you can do is you can find the discriminant to see if that's going to be the case. So let's just use the quadratic formula, and I'll kind of show you what I mean there. So since we're not sure if we can factor or not, let's use the quadratic formula, then I'll teach you this discriminant thing. We know that the quadratic formula is going to be negative b plus or minus the square root of b squared minus 4ac all divided by 2a. All right, so let's clean that up a little bit. I have negative 44 here. I'm not sure what that is. 2 times 9 is going to be 18. So I'll need to find out what that is going to be in our calculator we can use. So let's maybe try that. We have, what was it? 44 squared minus 4 times 9 times 60. So that gives me negative 224. Now I want us to think about that. What type of solutions is this going to give us? These are going to give us imaginary solutions. Complex solutions with imaginary parts. So that means that they're not going to show up on our coordinate plane. So even though this has an imaginary complex solution, as far as the solution where we're going to see them intersect in the coordinate plane, there is going to be no solution. There is no real solution to that. We cannot see them intersect in that coordinate plane. Okay? And that's the trick, just while I have you. If you're not sure if something can be factored, use the discriminant. Use b squared minus 4ac. And if it's a negative, you know it can't be factored, right? Because it's going to be imaginary. But the discriminant trick, you guys, is that if you use the discriminant, if your discriminant is a perfect square, then it's factorable. So if you got a discriminant that was 36, that means you can factor. If you got a discriminant that was 12, that's not a perfect square. That means you can't factor it. Use the quadratic formula. That's just a little trick. I'll throw that in for today. Okay? At this point, the substitute can stop the video and you guys can work on the worksheet. I am going to do the U-tries in case people have some questions at home or they need some more attention. So sub, you can stop the video and we can work on homework. And if you're still with me, let's do these U-tries. And I'll do them fast since you guys can go back and forth and pause and stuff like that. Okay. All right, so in U-try 1, notice that we have a very simple equation here that x equals 1. So that means that I can put that in place of this equation. So in place of x, I'm going to put 1. So I have 1 minus 3 squared plus y minus 4 squared equals 4. So I know 1 minus 3 is negative 2. And we can simplify this a little bit. So negative 2 squared is 4. And, oh gosh, well, I'm going to have to write this out, right? Y minus 4 times y minus 4, and then equals 4. So I have 4 plus, if I distribute, I'll get y squared minus 8y plus 16 equals 4. Combining like terms, you get y squared minus 8y plus 20 equals 4. You can get one side equal to 0. Y squared minus 8y plus 16 equals 0. And hopefully you recognize that as a PST. Oops. You have y minus 4 squared equals 0. So that means that y equals 4. Here we knew that x equaled 1. So your ordered pair would be 1, 4. Make sure you always put x first, then y, okay? All right, again, if that was too fast, go ahead, rewind, and kind of follow the steps from there. Okay? You try 2. This equation looks simpler to me than this one. And I noticed that I could just subtract x to get that y equals the opposite of x. And so that's what I'm going to use in this equation up here. So I'd have x squared minus y minus 6 equals 0. But what did I say I can put in for y? The opposite of x. So notice that gives me x squared plus x minus 6 equals 0. Ooh, this looks factorable. So if I use x plus 3 and x minus 2, I get the last terms that multiply to negative 6. My outer inner gives me x, so that looks good. And so this tells me I'm going to have that x equals negative 3 or x equals 2 as solutions. But remember, we need to use this to find out what the y values are, okay? So one of my x values was x equals negative 3. When I put that in, y equals negative x, notice I get that y equals positive 3. So that means one of my solutions is negative 3, positive 3. Well, another x value was x equals 2. And again, when I put x equals 2 into this expression, then we end up with y equals the opposite of 2. So that's just negative 2. So that means that we're going to have x equals 2, y equals negative 2. So 2, negative 2 is another solution. Okay, so you try 2. All right, you try 3. I will use this here. This one looks a little too complicated. Maybe I'll use this. A lot of us like isolating y, so we can do that. I'm going to say that y equals 6 minus x. Is that okay? Do you want to write it as negative x plus 6? Would you like that better? Okay. We'll do that. And so this is the expression that we'll be substituting into that other equation. So this equation has 3x squared plus y squared equals 12. And in place of y, I'm putting in negative x plus 6. So that gives me 3x squared, and again, this negative x plus 6 squared means that I can multiply that by itself twice. Okay. So I have 3x squared, and then negative x times negative x is a positive x squared. My outer negative 6x gives me negative 12x, and then 6 times 6 is 36. And then I still have that equals 12. So I can combine like terms. 4x squared minus 12x plus 36 equals 12. And then I have 4x squared minus 12x, if I get one side equal to 0, plus 24 equals 0. Now I look here and I need to solve this somehow. And I see that they're all divisible by 4. That'll help. So I have 4 times the quantity x squared minus 3x plus 6 equals 0. And when I look at this and I think about factoring, it's pretty obvious I can't find factors of 6 where the outer inner is going to give me negative 3. So that means I can use the quadratic formula. And use the quadratic formula, just ignore the 4. The greatest common factor, that constant, isn't going to give you, isn't going to affect those solutions at all. We just want to have this piece here. So let's use these values with the quadratic formula. A is 1, B is -3, C is 6. Okay? So we have x equals the opposite of -3 plus or minus the square root of b squared, so -3 squared, minus 4ac, so 4 times 1 times 6, all over 2a. So let's see what we get. We can clean this up. That's easy. The opposite of -3 is 3. 2 times 1 down here is 2. And let's see what happens here if I take -3 squared minus 4 times 1 times 6. That gives me -15. Oh boy, we have a negative value here under the radical. That means that we're going to have imaginary solutions, which we don't see in the coordinate plane, so we can say no solution to this either. Okay? Hope that helped, guys. Okay, have a great day.